Hello, and once again welcome to my workshop. Today we're going to do some, well, measuring and realignment of our laser today. Servicing of our laser. And in doing so I've found out a few things actually that I will have put right. First of all, you'll remember a few videos back me showing you a Mahoney measuring meter. This is a watts meter. What you do, you put this anodized aluminium block in the path of the laser for a measured period of time. And I'll show you how to do that. And of course it registers on here the watts. Now if you can pick that up, plainly on here it says that the time exposure then for this particular meter is 30 seconds. Okay. In their printed article or explanation of how to use the meter, it clearly states and underlined in bold 37 seconds. Well, I did it for 37 seconds. Someone at the Mahoney factory, I think, got a bit confused because at a 50% setting, sorry about all the scribble, but at 50% setting, my laser was putting out 93 watts. Obviously there was something wrong, unless I've got a 200 watt tube. So then I reset. Actually what I did was I just drew a circle. I think it's first of all, I think it was 12 millimeters in diameter. I'm not sure the exact figures, but it was roughly 12 millimeters in diameter. And a straight line through it. And I asked, when I in laser cut, I just said, look, both were set on a cut. The one was set at both of them were set at 1 millimeter per second. And if you've got a circle with a diameter of 12 millimeters, it's roughly about 37 millimeters long. So, which gives you the correct time of exposure of laser time on. And the straight line through it, and I'll show you in a minute. In fact, I'll show you now because it gets confusing me trying to explain it otherwise. Okay, so this is what I'm trying to explain. This is roughly about 12 millimeters diameter, and you've got a straight line here. Well, the program is set up on two different layers, a blue layer, a black layer. Blue layer comes first. I know that the laser won't fire at 5%. It fires around about 10%. So what will happen, this is I think 10 millimeters long, and I've set the speed of cut to 1 millimeter a second, so that gives me 10 seconds to press the start program and to get the Mahoney meter in line with wherever I want it, whether it's at the end of the laser or down near the head or anywhere in between. And then it'll start after 10 seconds. It gives me 37 seconds of a measured 37 seconds of beam on time, where you have to put the Mahoney meter, that black anodized aluminium block. You just play the beam on this, and the Mahoney meter measures how much heat is generated or picked up via this block, and it's within 1 or 2%. You know, it's really negligible, and you know, the accuracy, they're pretty accurate. So what I found out was, obviously the Mahoney meter was reading double what it should have. So I immediately then, if I can get out of this, no, I don't want to save anything, and open. Here we go. Okay, this one is very much smaller measured amount, and you can of course trim the diameter of this circle to give you exactly 30 seconds of beam on time. And the way you trim it is highlight it and size, and then alter the size on you. You got 9.2 millimeters in diameter, and that gives you exactly 30 seconds of beam on time. So, you know, you're as accurate as you can be, and that's the easy way of doing it. Okay, so I found out that it is indeed a 30-second meter, not a 37-second meter, because immediately I altered the time beam on. I was starting to get more accurate readings out of it, but I noticed that there was still something wrong. For instance, I was expecting, you know, at say 50%, I was expecting to get somewhere in the region of, well, about 60 watts, because I know it's not a linear power output. And I'll get something and show you a little bit more accurate. Okay, so this is a situation with relationship to percentage power on the readout, then, or what you set it at, and the actual watts that actually comes out of the laser. Now, it's not a linear relationship. And it's something like this. It will jump up here. So you have 10 to 100 watts. Okay, and 50 in between. Sorry about my scribble. The laser doesn't fire until 10 watts. Okay, which is about 10%. Okay. And what happens then, you get a fairly steep rise like this, and then it tails off like this. And you get 100 watts there. So you can see it's not a linear affair. And in actual fact, what I found out yesterday was that, now I did suspect, and the engineers told me that generally at 85% output, the laser will be producing 100 watts. In actual fact, it's close, but it's actually 90%. 90% on the, if you set the percentage output, okay, it will be giving, I proved to myself yesterday that it actually is producing 100 watts pretty well exactly at the end of the laser. And that's another thing too with lasers. As the beam bounces around the machine through the mirrors, you get a certain percentage of loss of power through each mirror and the lens. So that's 1, 2, 3, that's 4 areas where you are going to lose power. So in general terms, you are going to lose between 3 and 5 watts by the time you get to the material, the laser that's coming out. Sometimes you can get it better than that if you keep your mirrors really clean and really well aligned. Now that's something else we're going to maybe have a bit of time to do today. Because also I found out that the mirrors aren't quite lined up. And I'm losing a little bit. Now, I'm jumping around a little bit here, but I hope you understand that this is a rough example of the power output, the actual power output of the laser, and the set power then in the program. Like, it's not a linear affair. If you put in 50% output, you're going to get something like 70 watts or 65 watts. It's not a linear thing. So it's a fairly steep climb, then the climb gets less as you get up to the top end of the output. So I hope you understand that. Now then, do you remember about 3 videos back I showed you a Gaussian shape? I'll just go back to it now. So in a couple of videos back I showed you this shape, and this is the actual shape of the laser beam. It's not a square beam or anything like that. It's round, but it is cone shape or Gaussian shape, bell shape. And when it meets the material, the measurement of 0.2 millimeters of the actual beam, or slightly less, is from approximately here to here, and it has sort of a pointy bit, shall we say. Now this is at the head. Now the focusing lens just focuses the beam to a smaller beam then, more concentrated energy beam. When it comes out of the end of the laser, it is actually 12 millimeters. I know in a lot of the manuals you'll see, oh, a 5 millimeter beam. Well, it's not. Whatever size the orifice is out of the end of the laser beam, that is the size of the beam. But don't forget, it's a Gaussian beam, so the extremity of the beam is weaker, and as it comes into the center of the beam, like this, it gets more concentrated energy. Okay, you'll probably notice a few changes of clothing because I'm actually making this video over about a week's period, so bear with me. When you get your laser, probably the first thing you should do is check the setting of your mirrors. Now to do that is very easily. Now what you'll need to do is get yourself some, this is just white card, and it's 220 gram weight, Okay, so it's fairly thick card, or regarded as card, it's thick paper. And you need to cut out, with your laser, some round discs like this. Now in our laser's case, we use 25mm mirrors. So there's a lip where the mirror fits in, so the viewing part for the laser of the mirror is 23mm in diameter. So you need to cut out some 23mm diameter circles. Now these are your laser targets. These will tell you exactly what part of the mirror your laser is actually hitting. So I'll show you how to do that very, very quickly, how to write a program in LaserCut 6.1. Okay, so very quickly, all you need to do is get the circle tool, or bring it in here, just draw any circle like that and zoom into it. That's a bit oval, but it really doesn't matter. Then come up here and get the highlight tool. So what you need to do is highlight, select size, untick this, and just put in here 23.0mm and 23.0. Oh, a little bit far over there, 0.0, and press OK. So that now is a 23mm diameter circle, but we want quite a few of them. So what I'm going to do is come here and I'm going to say I want 3 rows. Sorry, no, 5 rows that way, 3 rows this way, and we better have them 3 and 3. That's 3mm gap in each direction, and we press OK, and there they are. So we select them all, and we want to cut, so we come here, and 1mm is a bit slow, so we're going to go 10mm a second, 12, that's okay to cut that card, and press OK. Now we'll just send that file to our laser and we'll cut them. Okay, so you get your piece of card. You will need to put magnets just on it like this. These are fairly weak magnets just to hold the card there, because the blower from the jet will actually just blow the paper out of the way. And indeed, when you're cutting the discs out, what I do is, I follow the laser around, and as the laser is nearly finished, I just put my pen on it. Otherwise the air blowing nozzle will blow it underneath where the laser is, and it's going to cut what you don't want. So simply, I'm using the keypad now to move the head in the right position. Okay. We'll just automatically zero the Z now. I just want to show you this. The program is in, and this is highlighted, the program is highlighted, but you can't move the head around. You must take that off highlighted, then you can move this around. Okay, so I want to set that as the datum. Okay, now that's set as a datum. Now we'll do a test. Okay, that's where it's going to cut it. And now we can press start. To remove a file from this control unit, you just simply highlight like this, press that to delete, and press that, and it deletes the file in the memory. You can't move the control, or rather you cannot move the head until you unhighlight that. Then you can move the head.